Okay, let's get started. So welcome all. This is Patina webinar, and the topic of today is Web Feature Service number 3, and how that is acting as a kind of pathfinder for modern practical OGC spatial data APIs. My name is Ilkka Rinne. I'm the head of customer experience and interoperability here at Patina. And I'm going to run you through this webinar, which will take about 1 hour, and we have some space at the end for questions and answers. But you may post any questions using the chat functionality of the webinar. So there should be a chat box in the control dialog there. You can post any questions there. I may not be able to answer them as soon as you type them, but I will make sure to address them at the end of the webinar anyway. So welcome. One or two things. During this webinar, I will also be making some polls to activate you. So when I do so you can use the poll, the functionality will kind of pop up to you, and you can just give your answer on the question, and we will go through the results after that. And the other thing is there is one handout PDF provided for you. It's also accessible in the user interface under handouts, and that is a PDF file with a lot of links that are connected to the topic of today, because I have not provided all the links within the presentation. So you may want to download or grab that to yourself before leaving the webinar today. So just to get us started and a bit activated, I would like to actually start with a poll right now. So the first thing that I would like to know is how does your organization use Web Feature Service, some version of Web Feature Service at the moment? So, and I will launch the poll now, and you can, we'll take a minute or two to collect the answers. Okay, great. So the results, what you provided are here. So most of the people, you're already delivering spatial data using some version of Web Feature Service. So 86%, that's really great. So this is probably very good topic for you to attend. 36% we use Web Feature Services provided by other organizations. So just a reminder, you could click more than one option here, so it doesn't add to 100%. 7% only said that they're not using Web Feature Services at all, and a few people say that I don't know. So you may not be the technical expert of your organizations to answer this. Great. So it's that's very good to know as a background. So moving on to the actual content. So what is Web Feature Service 3.0? Or so it is actually a new standard which is still in progress. So it's a completely redesigned version of the existing Web Feature Service 2 and the accompanying filtering coding specification, which you have the ISO numbers 19142 and 19143. And it is currently being developed in the OGC Web Feature Service slash filtering coding standard working group. And there is a cooperation between the OGC and the ISO TC211 group. So because the idea is that this new version, of course, will also be ISO standardized. Maybe the most important things to distinguish this new version from the existing web feature service standards is that there is this RESTful approach that you can, the idea is that you can access feature data following the patterns outlined in the OGC W3C spatial data on the web best practice recommendation. So what that actually means, I will show a bit later. There's also the idea that what is being standardized here is spatial feature specific behavior of practically any web API. So if you have an existing service API which does a number of things, you can just standardize that for the feature specific parts, and then your API will be Web Feature Service 3 compliant, even though it does provide additional functionality which is customized to your specific service. And how this is being done is also a bit new to the OGC process. So the group really wants to get a good draft out, try it out, implement, do server implementation, do client implementations, solve any of the issues that can be found, and only then standardized when something really, really works. You have a specification that actually does what it's intended to, and there at least the most obvious problems have been solved already before making it a final standard. So it obviously makes a lot of sense to make something that is really ready to use from the day one. There also another aspect on this is that it's not really in the field of the OGC to standardize how web APIs in general should work. So how the Web Feature Service 3 approaches this is that it takes something that's already there, has a really good traction already for describing a generic web API, and that is a thing called OpenAPI 3.0, previously known as Swagger, and that is a way to provide machine understandable service capabilities, basically. So what operations are available out there, how can you use, and what request parameters allowed, what kind of response can you expect from these operations. And all that is described in a way that's generic. It's not OGC specific at all. And this actually is a very big step, because then you have a lot of new tools, new clients that are able to interact with the service, with the capabilities, what's out there. It doesn't have to be OGC or spatial data specific. The other thing is that it really has a first-class support for something else than GML, which is JSON or JavaScript object notation. So it's a bit of a more modern web developer-friendly format that it has become pretty popular during the couple of last years. And doesn't mean that you could not use GML still. You can with this new version, but by default, all the services are providing JSON and also HTML as the data encoding. And the HTML thing is actually something that the idea is to provide something that is browser accessible. So unlike the other previous web feature service services, now you can just go to the website, kind of the address of the server, and you get a web page that is that you can read. So it's in HTML. So you have landing page for the entire service, but you also have HTML encodings for describing the data collections, describing the API operations, and also describing the actual features. So depending on how you decide to implement that, you can have a service that is in itself usable by a regular web browser. I was talking about the RESTful approach here. There's some examples here. It's actually copied from the Web Feature Service 3 GitHub main page. So just an example of how this new way of structuring and presenting data in Web Feature Service 3 changes what you're probably used to with previous versions. So you have the landing page, which is just the main address of the service. And then under that, you have information about the data collections that are offered / collections. And if you specify a certain collection and underneath that, a certain feature ID, you have a permanent URL which points to that particular feature ID within particular collection. So you can actually quite easily make addresses for addressing individual features using Web Feature Service. And also, if you don't have the feature ID, you can still make simple basic queries against the collection, of course. So it's just, you can use something like Bountybox. You can use something like time, and also you can filter by the properties of the actual filters. And if you need something more, then you need to use some of the extensions of the standard core. This is a slide, which I got from Clemens Portil, who is a co-chair of the OGC Web Feature Service /filter encoding standards working group. And this is the updated timeline of the new Web Feature Service 3 core standard. So where we are going now is approximately the red dotted line there, and means that we already done like 2 years from the initial implementation, the preparation phase for this new standard. And now we are moving into the first release candidate, and also gradually towards the OGC and ISO final standardization process. So during all this time, it's been pretty open. So you can just go into the GitHub page of the Web Feature Service SWIG, and you can see what has been proposed there. You can participate in the discussions using you can see which of the issues have been identified and so on. And now things are kind of getting stable and moving into something that can be fixed as a standard. So this is an interesting time. Now you really have a very good idea already what's going to be included in the core Web Feature Service 3 standard. What's also happening at the same time is that this whole idea of thinking in a new way within the Web Feature Service 3 standards working group has caused also the other groups and other people within the OGC community and the spatial data community to think that should there be something common, or do we need something else than just the access for features which are following this new approach and these new patterns? And it really seems that this is just a opening of this discussion and this new progress within the OGC. I'm sure that there will be other OGC services and other groups who are willing to follow the tracks, follow the path set by the Web Feature Service standards working group team, and kind of redesign or rethink what the their services are and make it more compliant with these ideas. To kind of facilitate that, the OGC staff and also other standards working group people there have been thinking of that there needs to be a new way to define the common bits in these new resource-oriented OGC spatial web services. Now, these, as you probably know, these common bits already existed for the previous or the existing generation web feature services. So for each of those, you have the capabilities, documents, and then you have a set of operations like get features. For web feature service, you have get map for web map service. You have get coverage for coverages and so on and so on. There is this common structure and common things that you can always find in the capabilities, for example. And now, now that we are moving away from the traditional capabilities document approach and more into this generic open API based way of describing the services, we still probably want to make sure that the different new OGC APIs work in the same way for those parts that can be shared. And there is something that's not going to be finished by when the Web Feature Service 3 is standardized, but it's probably going to be used, these common bits are going to be used for the following OGC standards which are following this approach. And really the whole idea within the OGC, different OGC services and different OGC APIs, the idea is that you can actually take these feature specific requirements and just apply them to any web API to harmonize the data access or data processing or whatever behavior. But you don't really have to say that this is a service that's only web feature service compliant or only web coverage service compliant or web map service compliant, but you can have a service with different operations combined into one API that basically the same API contains feature access patterns. It may contain coverage access patterns, map tiles. So depending on your use case, you're not limited to providing a server software that just supports features or just coverages. And also, as I already mentioned before, you can also, of course, declare a kind of widen what's available in your API by saying that, okay, it's also complying with another standards by a completely other standards body. It can be something that is just proprietary for your specific APIs, for your dedicated client applications, for example. And still can be part of the whole, which is described within the same open API description. So you can have a client software that can read this whole thing and just pick the pieces that it understands and use them. And this is a new way of thinking of how OGC web service standards should work. And this has really picked a nice traction. I think this is the way things are going to be built in the future. You have spatial data access building blocks, which you combine and you just say within the capabilities or the open API description, you have an endpoint, which is the /conformance, which just lists all the conformance classes that the particular API supports. So that's the way to know whether you can understand how this, how can you actually access the features for this? Is it declaring to be compliant with Web Feature Service 3? Is it compliant with the new upcoming web coverage service, and so on, so on. So I think that's a very interesting and very good approach to building something that is much more flexible than the current standards. Okay, so to actually show you something tangible here, I'm using a use case for a project that we've been working with Vaisala and the Finnish Meteorological Institute, and it's called Simple Observation Features Pilot. And the project is a kind of, it has two parts, or two pillars. One is the idea to make a proof of concept Web Feature Service 3 server for delivering weather and air quality observation and forecast data. And the other one is defining a data encoding for that kind of data sets that actually allows the data to be put on a map using existing WebGIS applications and libraries. So you don't have to do a client that is specific to the weather data or specific to air quality data in order to actually to at least put the data on the map somehow and just get the basic information from there, and if necessary, be able to build a really minimal code bit to actually visualize the data a bit better. So as I already mentioned, this is something that we've been working with Vaisala and FMI, and the other part, the interesting data encoding part here is that we take the, as you probably know, the Web Feature Service standard does not really define the data model for the offered data. So it means that you have to somehow harmonize, standardize, agree on the data model and the data encoding in order to get true interoperability with Web Feature Service interfaces. And as it is, if you, for example, you take Inspire data sets, they're probably most likely they are using a complex feature XML, GML encoding, which is not always very easy to understand with just a out-of-the-box GIS client software like a web client software like OpenLayers, GDAL, QGIS, and so on, Esri tools. So it doesn't. Usually, you get some kind of issues with the complexity of the GML there. So you might not even get the dot on the map or something like that. And the idea that we did try to do, we are kind of finishing in this pilot project is that we take the observations and measurements standard, which is the ISO standard for observation and forecast data, and try to come up with a simple data model that's using GeoJSON. And we've done a proposal for that, and we also at the same in parallel we also did a simple feature GML encoding of the same simplified model. So both are actually available, and you can find the links in the handout. And this has already been proposed as an alternative encoding for the observation measurements data within the Inspire. And also there is ongoing discussion on the standardization options for this kind of GeoJSON encoding of observations and measurements within the OGC. So it's still open, but it looks like there is a certain degree of interest in saying that, okay, I really want to use the standard ORM model, but I want to encode it in GeoJSON or simple feature GML that is not using complex structures, but it's something simpler. The other thing is, as I mentioned, the actual proof of concept server, and it's actually quite similar approach to many of the web feature services out there, is that there is this front end part which is handling the new web feature service 3 requirements and serving the users. And then there are some kind of backend integration modules which are attached to various data sources depending on the configuration of the service. This has actually been implemented using Node.js, which is a server-side JavaScript engine. It's been there for quite a while, and it's a kind of lightweight, modern way to code server-side applications. It has worked quite well for this case. And then in our case, then we have this service that I'm going to demonstrate in a few minutes. And in this case, it has been configured in a way that there is a backend module which is actually talking to an existing SmartMet data server within the FMI that FMI is providing, and kind of taking the data from there and offering that through the web feature service 3 front end. And the whole front end project is open source, so you can just take a look at how we've done it. It's still work in progress, so it's not 1.0 yet. But you can just, if interested and you know your code, you can just go there and see how we've done it. And the backend modules really depend on who's going to implement that, whether they want to make that open or not. So the FMI people are okay with open sourcing that. For example, it has not been decided whether the particular code to integrate the Vaisala backend systems can be open source yet, or whether that will remain proprietary. But the whole thing in here is that you can just take the front end and that will implement what you need for web feature service 3, and then you can basically just come up with your own integration into your own systems to actually fetch the data. So you can use this code to actually build your own specific web feature service 3 server if you like. So now I'm going to the demo part. So let's hope everything will run smoothly. I'm going to show you a live service which is running on this web feature service 3 pilot server software that I've been developing, and it's running on the FMI server. And the first thing that you'll probably notice here that this is the address of the service. So basically, this is not the capabilities document. It's just a landing page. This just says that, okay, I am this server. You can find me in this address, and then it has a set of links which will lead you forward in whatever you want to do. You have this link to the conformance declaration, you have the API definition, and then you have the metadata about the collections. And if we now go to see how that Open API description looks like, you can just click on this link here. So what you see here is actually the Open API description turned into HTML page. As I already mentioned before, there is this thing that almost all the resources you have within the web feature service, you can find that you can access them through the kind of browser-friendly way, so as a web page, or you can just use them, access them in a kind of machine-readable, machine-understandable way. So this is the HTML version of the API description. You have a list of the operations here, for example, get features, open data, which is the name of the observation data sets that are provided by this service. So you can just get a glimpse on what this operation does, what is the address of the operation, what it does. It will describe a brief description of the operation, the kind of documentation, how to use this particular operation. So you have the list of parameters, what type they are, descriptions. So as you can see here, I already told that there is a way to set a bounding box limit to the query, also time limits. You can choose things like I only want observations from a particular location using the name of the place, for example, and so on and so on. So you have a nice documentation of the operations of the whole API as a web page. So this is not a separate application. This is actually part of the server, what the server provides. Then you can, if you are not accessing this as using a browser, you can see the same information in JSON. So if you're a machine, this is what you'll see basically. Instead of the HTML page, you will see bit of code, bit of JSON structure, which is the OpenAPI compliant version of the same information that you saw previously as a web page. So you see that if you just put like a slash here, you get to the landing page. Slash conformance, you get the list of the conformance clauses, you get information about the data collections and so on. So this is machine readable, and this is human readable version of the same thing. And if you go further here to a particular data collection. So let's say I'll type in collections, open data, 1 hour resolution. I get a web page again, which is describing this particular collection of data, collection of features. So it says that this is what I have. This is the description, and you can get this is the collection metadata. So it's a description of the collection, and you get a link of which is providing the list or the items, the actual feature data here. And of course, if you are not a human, you probably you kind of automatically redirect it to the JSON version of the same thing. In this case, I'm kind of forcing that using this query parameter f equals JSON. You can see the same thing as a kind of machine view of the thing. You get links, and you get this is the kind of the collection. You get a link which is pointing to the items resource, which is what I'm going to be showing you in a moment. So this is quite nice. You have this dual view of something that is browser compliant again, and then something which is more like intended for machine use. Already going too far here. I'm just again showing the same thing. If you make a query, then by default, if you're using browser, you get the HTML encoding of the results. So in this case, in this server application, we decided instead of a list or table of the features, we decided that why not just plot them on the map. We know that these are geospatial features. So you have a set of links here, and then you have the features. And in this case, the features are already plotted on the map here. So you can just, it's a map, dynamic map. You can zoom out. This one is using leaflet rendering and OpenStreetMap data. And then you click on the feature and you get information about the properties of that particular feature. So this is something that when you have this thing, which is like a service, which is not just machine oriented, but also provides HTML, you can make a web page that is actually part of the server, but it's still something that is very accessible using browser, which is quite nice. Again, taking this forward and seeing how the machine client would see the same information. It is a GeoJSON feature collection. So you have a set of features with particular properties, and then you have geometries which has the information on where that particular feature is located on the map. And just to kind of complete what my demonstration here, I'm going to take this information, just copy that, go to another website, which is called web applications called GeoJSON.io, which is a tool where you can just paste in GeoJSON feature collection, and they'll show you that on the map. So I'm just going to paste this result in here. And what you can see here is that there is these particular features. So in this case, weather observation features from Helsinki around the Kumpula area where the FMI observation station is. So you can actually see that on the map. You can see how that's been rendered. And this is a generic tool. So this is something that just understands GeoJSON, but it doesn't not have anything to do with OGC. And that's kind of showing that we are getting where we want to go with this pilot. So we can actually do something that is usable. We see that the Web Feature Service 3 API is something that is not too complicated to implement. And also that we have a data encoding format that is actually usable by regular clients. So at least you can get the data on a map, and it would not be too difficult to develop something like observation time series visualization and something like that, or something like that on top of this. So it's a great. I think it is a great thing that we've seen that this is actually working and this is doable and it's not too much trouble. So if you compare implementing this to, say, implementing Web Feature Service 2.0, it's probably going to be a lot less work to get the core functionality of the Web Feature Service 3 together. And it also means that if you're not doing that yourself, you can probably buy that cheaper, which is great. And you can just get additional feature functionality that you really need. So it's a kind of minimal core standard implementation. And based on our experience on this, it looks like it's relatively well. We still have things to do within this pilot in the service here. For example, you can see that even though this is a observation station, you're not actually seeing the name of the observation station here as a property. So there are things that we still need to do, and it's still work in progress. But I just wanted to show you that that it already works and it can be improved quite easily. Okay, getting back to the presentation. At this point, I would like to do another poll, which is based on your previous knowledge and the information that you got from this webinar by now. Do you think that Web Feature Service 3.0, or it might actually be called something else? Eventually, there's an ongoing discussion on that within the OGC right now. But whether this new standard for accessing feature data is interesting for your organization. So I'll just start this new poll, and I will give you again about 1 minute to answer. Now, in this one, you only have one option you can choose from. Okay, the final votes in. And we'll also share you with the results. So it seems that 80% of you are already preparing for that. You're already building support for this new standard, which is, I think it's more than I expected, actually. That's very nice. And also 43%, almost half, is already thinking that, yes, we should start planning how to take it into use right now. And 30% are a bit more hesitant to start, but yes, definitely interested. So waiting a bit more before it becomes popular. And no one actually thinks that this is not something that they should invest in. And 10% not sure. We need more information, which is also great. So obviously, this is one of the reasons why you're here, right? To get more information. Good. So what I'm reaching the end part of this this webinar now. Going soon, you'll be able to ask questions, and I will try to answer them as well as I can. Before that, I would like to give you some pointers what to do now if you're really interested in this topic. So I already mentioned the data model, which is the simple observation features. That is the GeoJSON profile there that has this this address actually contains two sub pages, one for the simple feature GML profile or the GML encoding, and then the other one is the GeoJSON one, which has been the topic of today in this webinar. You can also go and play with the service that I use for demo. It doesn't need any authentication, so you can just go to this address and play around with it. It is just to remind you, it's actually it's providing real live observation and weather forecast and air quality observation data. So it may not be polished as it is, but it is actually connected to the real data sources. And there are two events you might be interested in. First, in June, there is a OGC API hackathon, which is focusing on coverage data, map tiles, and processing. So it's going forward from the web feature service alone and going to these other aspects that the OGC might be interested in developing APIs for and this RESTful approach for. And this one is hosted by Honest Survey, and it's in London. I've never been to this Geovation hub in London, but I've seen some pictures of it and it looks very interesting. So if you can go there, certainly recommend it. You have to register though, so there's a link to this event webpage where you can find the registration link for that. And then next autumn, something that is connected to this pilot project, there is an Inspire event that also Spatina is part in arranging, and that's going to be held in October, so 22nd to 24th of October in Helsinki. As you might know, that there is no Inspire conference, the yearly Inspire conference this year. So this is a bit more hands-on problem-solving event, which is not just focused on the Inspire implementation, but what could be done with the European spatial data right now and how that should evolve in the future. And there is this data challenge that's being arranged that's connected to this event, and that's going to be something that you can register already this spring. And if you're interested in working with this data challenge, solving actual problems like urban commuting, how these modern data, weather data, air quality data, and so on can be combined with that to make modern urban commuting more pleasant, more efficient, and so on and so on. That's just one of the themes that are probably going to be part of this challenge. So the actual hacking, the teams actually working with these challenges, it's going to be in September, and the results are going to be presented in the Inspire Helsinki event in October. So there's this link here, then you can just probably want to save the dates if you're interested in Inspire and also the European spatial data in a bit wider sense. So now the floor is basically yours. You can use the chat functionality as already mentioned if you have any questions regarding my presentation here or the pilot project or the web feature service in general. I'll be happy to try and answer them. You can still post a thing about the questions. I'm going to just briefly show you while waiting the website that I already mentioned here. For this Inspire event. So Inspire Helsinki 2019. So this is still not completely finished, but this is more or less what it's going to be looking like. So this is supported by the European Commission Joint Research Center, but it's not really. It's organized by the National Survey of Finland together with the Ministry of Agriculture and Forestry, and we are just kind of our Spatina's role here is more on making sure that the technical things work and also especially the data challenge part of that. And so you can there will be much more information available. Currently, we don't really have a program that we can publish at the moment. We just have like a very, very preliminary list here on what's going to happen on which of the days. It's going to be like a lunch to lunch event. So it'll start with the lunch afternoon, and then there's a one full day, and then a half a day with the plenary sessions and keynotes and challenge awards and so on. But so you can find much more information later in this webpage. Also, there is this call section here. We don't have call for presentations for this, so it's more like an event where we try to come up with the program with plenary speakers, with people who really know what they are doing and can foster fruitful discussions. Right now, there is an ongoing call for challenges. So we are looking for partners for this data challenge with the questions that they want answered, with the data sets that they want to provide for this challenge and so on. So this call for challenges is open until the 3rd of May this year. So you can find a link here to submit a challenge proposal, which is basically just contact information, and what very generally what you have in mind, and then we'll come back to you and start talking about what you really want to get done. Any questions? Okay, if there are no questions, then I will just stop this presentation, this webinar, and I really want to thank all of you. A big crowd you came here. And I hope you found some answers to your questions, and you learned something new from this webinar. And after the webinar, we will send you an email which contains a survey which asks about a bit of a feedback on how this went and so on. And don't forget to grab the handouts PDF. So it has a list of links that are relevant to this presentation before you go. Okay, thank you, and goodbye.